Hello, everyone. My name is Alison Diana, and welcome to today's webcast titled HTML5 is not HTML, What the Security Professional Must Know. This event is sponsored by Wedge Networks. Before we get to today's topic, let's get some simple housekeeping items out of the way. This event is completely interactive and incorporates many social networking tools. You can tweet or directly post information to social media sites, including blogging platforms, bookmarking sites, social news sites, and social networking sites, all right from the console. Just scroll along the bottom of the screen and click on the Share This widget. Also, if you have a question for our speaker, please hit the Ask a Question button on your console, and we will get to your question during the live Q&A at the end. Wedge Networks will respond to any unanswered questions via email. You can also use the green Resources widget to download a copy of the slides to your desktop. In addition, there is a group chat widget, so click on that if you want to start or participate in a group chat. And every window you currently see, from the slide window to the Q&A window, can be enlarged or collapsed if you want to change the look and feel of your console. Finally, there will be some polling questions sprinkled throughout the event. We encourage you to participate in these polls, so please, when you see them pop up, go ahead and vote, and we will share those results with you. Now, why we're all here today. Today's eSeminar, HTML5 is not HTML, What the Security Professional Must Know, will give you insight into many of the features, strengths, and capabilities of HTML5. You'll also learn about the new security concerns that accompany these features and how you can address them. Here with us today to discuss these issues is Joe Bullman, Senior Systems Architect at Wedge Networks. Welcome, Joe, and thanks very much.
Thanks very much, Alison. It's great to be here. Good afternoon, everybody. Thanks for joining us today. We're going to talk a little bit about HTML5 today, and we're just looking at the agenda now. First of all, we'll go into an overview of HTML5, and just to give you an idea of the features and what's involved in HTML5. We'll also talk about HTML5 adoption today, where it's at. We'll look at some HTML5 security concerns, which I know we're all interested in, and we'll talk about HTML5 security defense. And then we'll specifically go into some WedgeOS deep content inspection technology from Wedge Networks. So HTML5 overview. So this isn't a simple upgrade, as you guessed. At 50,000 feet, we know that HTML5 is the fifth and, of course, most significant revision of HTML, which is the standard for presentation of Internet content. The HTML5 and related specifications are a very large group of features that enable next generation of Internet applications. These specifications, although I'm not including a full list of these features, but I'm going to roughly divide them into 4 groups. And the expected completion date is 2014, but many of these features are obviously already implemented. First of all, we'll talk about richer media. And that's the tags, audio and video content, 2 and 3D graphics, new style sheets. We'll talk a bit about the increased responsiveness of HTML5, and that's coming from web workers and WebSockets. We'll talk about local storage capabilities, which includes disconnected operation and indexed and SQL databases. And we'll also talk about the native support features of HTML5, and these are things like local file API, geolocation, and, of course, WebGL graphics acceleration. Traditionally, these types of features were provided by third-party plugins such as Flash and QuickTime. And now we can find, we'll go into that in further detail, of course. And the HTML5 spec is unique in that there's actually many specifications, and they're defined by 2 groups, the Web Hypertext Application Technology Working Group, which is quite a mouthful, and the World Wide Web Consortium, which we're more familiar with. So the first feature we'll talk about today is the richer media aspects of HTML5. So HTML5 includes new audio and video tags for embedding media. And what this means is that the browser will actually be responsible for playing these audio and video clips natively. So the codecs and everything will be embedded in the browser. This will be plug-in free. This will also allow developers to target mobile devices, desktops, etc., without concern for required plugins, proprietary type of licensing, anything like that. In addition, there's something called the canvas, the HTML5 canvas. And this is very important because this actually provides a very native feel to the graphics capabilities on the client side. And you'll see on the right there we've got Angry Birds. And of course, Angry Birds for Chrome has been written in HTML5. In addition, there's style sheets, CSS3, the new version of style sheets, inline scalable vector graphics, advanced markup type of things. So there's lots of other goodies in there, and this is not comprehensive by any means. The next feature we'll talk about is the responsiveness features. And the first aspect of that, if you recall, is web workers. Now, web workers give multi-threading capabilities to the client script on the browser side. So previously, the JavaScript and other scripting technologies ran on a single thread, and that was the same thread that user interaction was handled by. So everyone's probably aware or have seen the cases where you're downloading a site and all of a sudden it locks up for several seconds. We're not sure why. We can't enter anything. We can't click on links. Maybe we can't even see everything. And this is often because JavaScript is operating in the back end, performing a bunch of multimedia or calculations and logic in the background, preparing your page. And with the web workers now, we can see that browsing is going to be a much more responsive user interaction because we can now perform calculations and render content and even request additional content in the background unbeknownst to the user. And so you can see we just have a little, maybe a bit hard to see on your screens, but there's a little stock ticker application. And we'll talk about that a little bit more in the future slides as well. But that's a typical example where we'd be running something in the background and keeping stock symbols up to date in real time.
So productivity, Joe, must really increase with HTML5.
Absolutely, yes. It's one of the significant reasons that previously web applications without the help of plugins were really thought to be lagging behind native client applications.
Great.
The next feature, or the next part of responsiveness, sorry.
I'm sorry, yeah, I think this might be a good place to have our first poll, too. Let's see. Why do you think HTML5 is significant? Our answers are, it's the next version of HTML5. It replaces Flash. It contains a very broad range of features required to make native web applications usable. Or it's an open standard. Well, I think those are all very good reasons. What have you been hearing from the experts and the folks you talked to, Joe?
Yes, well, it's obviously a very complex answer. HTML5, as we've mentioned, brings a lot of the functionality in a standardized way to a ubiquitous set of devices like the desktop, mobile devices, etc. That's very important. These features themselves are obviously very important. It's responsiveness, it's media. And it's also an open standard, I think, which is one of the big things. So vendor lock-in and this type of thing are not a problem. And we, as we'll see in future slides, of course, we'll talk a little bit about the security implications of HTML5, but we think overall a better landscape for security. Great.
Well, let's look at the results, and then we can move on. So now you're looking at responsiveness, is that right, Joe?
That's right. So now we'll talk, the next part of responsiveness we'll talk about is WebSockets. Now WebSockets solve many problems that we've had with HTTP in the past and currently with web applications. It's asynchronous and full duplex, and that equates to responsiveness, and it's very efficient. So as small as a 2-byte header, and of course that translates to performance and lower overall bandwidth usage. And these are typically things that HTTP was never really good at. So in the top picture here, you can see on the top half is the HTTP request response mechanism. So each response has to come with a precursor request. And each of those requests and responses obviously have a lot of information in their headers, which we'll talk a little bit about later. In the case of WebSockets, after the client, for example, makes an initial handshake with the server is free to push down information asynchronously. And all of these messages that are getting pushed obviously have very little overhead in their headers. We'll talk about that a little bit more later as well. But previously, HTTP polling was the only way you could get this sense of dynamic updating of web pages asynchronously. And AJAX, for example, is one of those technologies that relied on that. So WebSocket is able to be used as an API, obviously, by technologies such as AJAX to provide this in a very efficient fashion. And just to give you an idea on the efficiency of that, on WebSocket.org, they've got a very interesting use case, and it's that stock ticker application that we've seen previously. On use case C, we'll just dive into that one. It represents 100,000 simulated clients, and with HTTP polling, we can see that it's approximately, I think, 660 megabytes of data over the duration of the test was transferred. In the case of WebSockets, that's as low as 1.6 megabytes of data. So that's a 500 to 1 reduction on traffic. So we can see how valuable WebSockets can be. In addition, WebSockets is currently supported in Firefox 7 and up, Chrome 14 and above, and it's also available in IE 6 through 9 with help of the Chrome Frame plugin, which provides all of Chrome's HTML5 features for Internet Explorer. The next feature we'll talk about is local storage. Now, the first part of this is what they call the offline application cache. And this allows applications, web apps, browsers to download all of the required resources for a specific web application, so it doesn't need to make further requests. And the developer of the application, of course, is the one that determines what all resources need to be downloaded, and then they create a meta file that actually tells the browser, you need to download all these applications. And the typical use case that we'll use, or at least I like to use, is the desert island without Wi-Fi or 3G, etc. access. And this is kind of an example we could talk about going on a plane, just generally lower bandwidth usage by having this ability to download all of this content. In addition to content, though, we also need a way of storing dynamic data. And this is where things like web storage and IndexedDB features come in. So this allows us to, and specifically the scripting side on the client browser, allows it to store information on behalf of the user. This could be information that may be synchronized later date. It may be there to reduce the amount of overhead, increase responsiveness. There's many useful usages of it. In addition to that, actually, there's a full web SQL database provision that actually provides, and you can see here in my little snippet of JavaScript, you can actually see that it actually allows us to do a full set of SQL select type statements. So very powerful way of storing information locally, improving the experience of the user, helping offline application usage, and potentially reducing bandwidth.
And this is something that could not be done previously.
That's correct. Traditionally, web application developers have had to store this information on the server side. And the trade-off has always been we usually have to access this information in a very fine-grained manner. But traffic across the web, of course, is not great. The latency is relatively high compared to local access.
Right.
So these kind of micro calls for data can now be executed locally.
Terrific.
Now, the last part of the features we'll talk about, let's just call them odds and ends. A very significant one, though, is called cross-origin resource sharing, or CORS. Now, this allows web applications to authorize traffic and resources for other domains that can be defined by the actual web application developer. And, of course, the whole purpose behind this is for greater integration between web applications. Now, we'll see a little bit in the security section. We'll talk about the single origin principle that that browsers follow today and why this is significantly different, especially when it comes to security. Another feature that's significant is local file access APIs. So this allows the client-side script have greater access to local file resources on the browser workstation or device. And in addition to that, there's many other features, of course, but form and user interaction tags are very useful, very important. Speech-to-text API, webcam access, etc. So it's, like I said, it's by no means a definitive list, and we'll talk a little bit more about how large the feature set is when we get into further slides. So we've talked a little bit about the features of HTML5. Now, we know that it's coming, or it's here now, but we know that the spec is not due to be final until approximately 2014, although many of them are already in last call. We can see today that there's much adoption currently in the marketplace. So we know that it's been adopted by obviously many influential or online organizations. And the really important part of this picture, I think, is look at all these names. And when was the last time we saw all of these names supporting the same technology? And of course, this is not a definitive list either, but these are the big ones. Apple, Google, Microsoft, Yahoo, Facebook, all of them supporting this specification in their applications. In addition to that, I've put some business applications. Salesforce and LinkedIn specifically are commonly used business applications that also use HTML5, especially on mobile devices. So the other really important half of the equation is the browser side. And we know today that HTML5 also enjoys strong desktop and mobile browser support. And this is evidenced by, there's a site here called HTML5test.com, and this is where I got all of this information from. So HTML5test.com grades your browser on HTML5 and related features out of a total number of points of 474. And Chrome, the version of Chrome that I'm using right now, Chrome 16 or Chrome 17, I guess, beta, scores a 374. And that, in my mind, is actually very high. There's many kind of obscure HTML5 features that might take quite a while for browsers to implement, and I don't think are necessarily going to be a loss. Yes, Alison.
Yeah, I was just thinking this might be another good time for a poll to find out what audience members' organizations' biggest potential adoption paths for HTML5. Using cloud-based HTML5 business applications, employees using non-business HTML5 applications such as social networking, building your own HTML5-based business applications or other. So if you could please just take a second and answer that, and then we'll share the answers in a minute. It'll be interesting to see what folks do there. What do you think the answers might be here? There were some good choices there.
Yeah. Well, I think the really interesting part was we look at all of the names and all of the reasons for folks to be at this presentation today, and I found it very interesting. It's a very interesting group of folks. So we do have, I'm guessing, folks who are developing HTML5 applications or potentially developing HTML5 applications, potentially using HTML5 applications through something like a cloud service. Mm-hmm. Obviously, we know that employees can already use these types of applications, and so it'll be really interesting to see the general mix of folks. And the other is really important to me too, because I'm very curious as to everything that all the different reasons, of course, why people are potentially involved in HTML5 going forward here.
Great. So we'll have a look at the results, and let's keep going. So please go ahead, Joe.
Okay, great. So we're just going through some of the desktop and mobile browser support. And like I say, my browser scored a 374, but I just wanted to give everyone an idea for how widely adopted this is. We have Google Chrome, Mozilla Firefox, Opera, Apple Safari, Microsoft Internet Explorer. Those are the desktop browsers. We've got, for tablets, we've got mobile or Firefox Mobile, iOS 5, Opera, RIM, Android, and of course mobile phones, much of the same, and more. So it really is a ubiquitous technology that is being adopted today. These are current numbers. These are production web browsers measured against the features of this site. And to give an idea of what kind of adoption there is for potential content, a really good resource, mepedia.com, which indexes video content, has, through a survey of 30 million videos from 33,000 sites, have seen this growth trajectory. And so currently, they're seeing 69% of H.264 video, which is a very common video format, is available for HTML5 playback. And we think that's a very significant indicator. And it's not easy to get these numbers, of course, because, for example, when I go to YouTube, it's a Flash video player. When I turn off my Flash plugin in Chrome, then YouTube will actually switch over to an HTML5 player. And so in many cases, we get a cloudy view of exactly how much adoption there really is. There's a lot of technologies there which will fail over. So if HTML5 is not supported in your browser, they'll fail over to something like Flash, for example. The other interesting stat that we've seen is developer adoption. Of course, this is a leading statistic. And so the Global Development Survey from Evans Data is showing, I know it's hard to see these numbers here, but it's 43% current adoption of the developers that were interviewed, 43% in North America, and a fairly large 58% in Asia Pacific. So that's a very significant amount of adoption of HTML5 technologies. And keep in mind, HTML5 technologies are quite a range of features, and so this includes all of these features. In addition, across the board, the planned adoption rate, I believe by the end of 2012, is around 75%. That's also a very high number. So I think we're just at the cusp of adoption here. So now let's get into the meat of the matter. So HTML5 security concerns. And let's talk a little bit about the state of the nation of HTML5 security, and then we'll talk about specific threats. So it is our belief, and I think the belief of many, that HTML5 is improving the security landscape. It's a transparent standards process, and that is the reason why I can stand here today and give this presentation, because I've seen not only the standards themselves, I've seen implementations of those standards, and I've seen open discussion of their issues. And I think that, when compared to a proprietary model, where the first time I'm able as a technologist to see a technology is when it's rolled out by the vendor. In addition to that, the HTML5 applications have restricted access to system resources. And once again, if we contrast that against today's plugins, which have full access to the system's resources, and it's up to the vendor to actually reduce that access to something that's considered to be secure. In addition to that, the corollary of that, of course, is that security moves into the browser's hands. So the browser is now responsible for all of these features. And in my mind, that kind of holistic perspective gives us the ability to provide a better end security product, because when it comes to security, a holistic perspective, I think, is always best, and a holistic implementation in this case. In addition to that, kind of a small thing, but I think a very important thing, is that HTML5 features are all contained, the patches of those features are all fully contained in the browser's update mechanism. So we're not concerned about multiple vendors and plugins and their ability to be updated in a timely fashion. If you keep your browser up to date, then all your feature implementations are up to date as well. We just have a little example of a Flash update. I hate to use Flash as the bad guy. Flash has been a fantastic technology over the last few years, and I think it's time for an open standard.
It's got to be much easier for IT departments who are obviously overseeing and maintaining and upgrading thousands of computers and devices.
That's right. Yeah. Well, in fact, we'll go into a little bit in a future slides, but I think that is it's difficult enough to keep a single application up to date across hundreds and thousands of workstations, let alone mobile devices. Right. But when you move into multiple plugins per device, then of course it is a cross-product problem. So now we'll talk about some of the published concerns of HTML5. Of course, with a vast array of features comes concerns, and I just wanted to temper this. that the European Network and Information Security Agency, ENISA, did a relatively comprehensive study of 13 of the W3 specifications covering HTML5, and they identified 51 potential security threats. So these are theoretical things that could potentially be issues with the specs at the time of writing this. Now, of course, the specs have already adopted many of these recommendations or worked around them, and we see that probably going forward more. But this is a good example of what's theoretically possible. In addition to that, we go to a site called HTML5sec.org or HTML5security.org, and identifies several known HTML5 vulnerabilities in existing browser applications or implementations. And so this is important because these are real-world things that have been found and are publicly reported and obviously fixed. And it even gives you can see the snippet here, you can see that it actually even gives you the versions of the browsers that are affected. Overall, though, we think it's many of these concerns are going to be mitigated, obviously, with implementation and proper security functions. So I'm going to divide these HTML5 security concerns into roughly 4 categories. And I'm going to say privacy and data leakage, and that affects things like local storage and geolocation information. Content-based threats, so new malicious JavaScript vectors like cross-site scripting, traditional things like buffer overflows and the implementations, and botnets, which is something that's unique to web workers and multi-threading. In addition to that, we'll talk about trust-based threats, and specifically cross-origin resource sharing, and then we'll talk about WebSockets and prototype or protocol exploits. So first, we'll talk about privacy and data leakage. Now, of course, we know that if a browser is compromised, it puts data at risk. Now, with HTML5 comes much more data than we're used to seeing in the browser traditionally. So we could have sensitive identifying business information stored in the local databases, which could be leaked. We have local file access APIs, which could expose files locally on that machine. Geolocation information, of course, which may be allowed to be collected by trusted domains, might be made available to untrusted domains, for example. Now, what about content exploits? Well, cross-site scripting is nothing new, but it's certainly one of the biggest threats when it comes to content. And it's when script is defined as script being injected by an untrusted third party and it executes in a trusted domain. And of course, there's pre-existing exploits, but HTML5 introduces new vectors and much more powerful APIs. And we'll talk a little about those as well, web workers and local storage, for example. And here I just have an example of a well-known exploit that affected IE8. And so they were able to execute, as you can see, custom JavaScript from the Bing website. And this can be very useful for a hacker. The next content exploit that we'll talk about is malformed content causing trouble in new implementations. And this is, once again, nothing new. But the difference is that we have a significant amount of new functionality being added to the browsers. And with that, it inevitably comes exploitable code. And here we have, for example, I think everyone's familiar with the iPhone on the right there, where iPhone had a PDF issue where a malformed PDF file could actually give root access to the device. And so you could go to the website, download that specially crafted PDF file, and your device was now unlocked. In addition, it can be used for things like just providing a denial of service attack, like you can see on the left in Chrome there. In addition, another content exploit I'd like to talk about is the background thread. So we alluded to this earlier, but background threads do give much more power to malicious client script. And the reason for this is because traditionally we're used to seeing if malicious JavaScript is executing for a long period of time, it locks the browser, and eventually we just close the window down, and it limits the amount of damage that JavaScript can do. Now with the concept of web workers, there's the potential for things to run in the background, unbeknownst to the user. And so we could leave browser windows open for long periods of time. We can potentially have them, this exploit could be cached locally, so every time you reopen that browser, it goes back to work in the background. And the types of attacks would be something like a denial of service, could be maybe internet port scanning, something like that, or browser-based botnets as a potential. The next group of exploits we'll talk about is trust exploits. And specifically the big one here, and the big difference in HTML5 is what's called cross-origin resource sharing, or CORS. Now, traditionally, web browsers have always honored what's called the single origin policy. And the single origin policy would prevent client script downloaded from one domain from accessing a different domain. And in effect, this creates a sandbox around the browser and the domain that you know that you're accessing. Now, this has been safe, but unfortunately, in implementation, it limits integration potential between web applications and web partners. So HTML5 introduces CORS to allow developers to trust other domains. And in the example here, you can see where potentially a script from CNN.com may be able to connect a port, could be a WebSocket, an HTTP connection, to another domain that the user is not actually aware of. This is really important because what it means is it fans out the level of trust, and it's purely based on server headers that the web application developer configures. And so I think one of the big issues here also is even the ability to inadvertently create too large of a trust network and allow, unbeknownst to the web developer, allow a hole where a malicious attacker can take advantage. The next section, the last section of the security topics we'll talk about is the WebSocket protocol specifically. Now, I think it's really important to understand the characteristics of WebSocket protocol, and this is fundamentally where we see that we need some new thinking to protect against it. But first of all, WebSocket connects over the HTTP port through what's called the upgrade functionality. Now, that means that essentially WebSockets are hijacking an HTTP port. In addition to that, there's no request or response protocol. So there's no, for every server message that's pushed, there's not necessarily a qualifying client request that details why that message is coming. And if we look on the right side here, we'll see what the envelope kind of looks like. On the typical HTTP request response, we can see a lot of identifying information in the request. So get/tech from CNN.com, there could be accepted content types, accepted authorization types, etc. So there's a tremendous amount of information just in the request. Then in the response, we have additional information. We know the content length, we know its type, we potentially have other third-party information in there. There's a lot of valuable information just in the headers. And of course, the response comes through in many cases in ClearScript or in a standard encrypt or a standard compression format. Now, that's very descriptive, but of course very verbose. In the case of the WebSocket message, we can see where the exact same content in this case, so the script, little scriptlet there that I've shown is also in the WebSocket message down here. And in the header, this is a little bit abbreviated, but it's fairly accurate that we have very little information. We know the length of this frame, we know the mask used to mask the script, and we also know whether or not this is the final frame. So this is the type of anemic information that's available through a WebSocket connection. And this is, without the URL or application headers, we know this makes reputation defenses quite difficult. Of course, the hijacking of the HTTP port makes firewalls very difficult to differentiate. And on top of this, data is masked. So this just further obfuscates the threats. So we talked a little bit about the concerns, and let's talk about the defenses. We'll start off talking about some of the traditional defenses that we're used to. So the first line of defense is actually the browser and application vendors. So these are the folks who try to design a preventative architecture and implement in a preventative way. But we know inevitably new architecture is going to create unforeseen vulnerabilities. And we also know that in spite of best efforts, that implementation vulnerabilities will exist. And I just have a little snippet from Chrome here. You can see how many pointers are being passed around. This is C++ code. Opportunities, of course, are going to exist with this amount of new code and just the tremendous number of new features that are being added to these browsers. No fault of the implementers. We also know about current endpoint security solutions. And so, for example, antivirus. And one of the chief challenges here is the individual points of failure. And, you know, in my experience, there's always been a certain percentage of machines in an organization that has hundreds or thousands of machines that don't get the appropriate updates or the software isn't even running properly. In addition to that, next-generation business devices such as smartphones and tablets are obviously going to have quite a challenge. They don't have the footprint, they don't have the memory, they don't have the CPU to execute these types of scans. Now, we move on to the network here, and we talk about firewalls and next-generation firewalls. So we know that blocking trusted HTML5 applications just isn't an option. It's necessary. These are necessary access, necessary applications. So like it or not, we're going to get HTML5 content. We also know that firewalls and next-gen firewalls aren't great at content-borne malware detection. And they're going to have a very difficult time differentiating embedded protocols such as WebSocket. Now, in the case of UTMs and secure web gateways, which are more HTTP defenses, we can see that we're going to have difficulty scanning the full HTML5 content. This is usually a performance versus accuracy. Traditionally, it's been a performance versus accuracy trade-off. And we can't do a great job of securing WebSockets because they don't have any HTTP information in them. So once again, we'll relook at that frame, and we can see how much or how little information is available to us. And traditionally, these UTMs and secure web gateways have required a significant amount of HTTP header information. So what do we do about this? Now, we've seen some of the new features, we've seen some of the concerns, and we've seen how traditional defenses are not quite keeping up. What can we do to supplement security in our organizations? I'm going to start off by going through just a use case here. So this is CNN.com to give you an idea of what composite or a mosaic of content is. It comes back with every hit of a web application. In this case, CNN.com/tech returned 99 separate content items for a total of 1.3 megabytes. 19 of those were HTML with embedded JavaScript. That was 77 kilobytes. There was 20 explicit JavaScript files. This is just JavaScript. 800 kilobytes of code was downloaded on something as simple as CNN.com/tech. In addition to that, there's 56 image files, 3 different formats. And what's also interesting is when you look at where did this stuff come from? I had CNN.com. However, I have images coming from Turner.com. I think that kind of makes sense. I think Turner Broadcasting owns CNN. Another ad came from 2mdn.net. I'm not really sure where that's coming from. RevSci.net and InsightExpressa.com, Connect.Facebook.net, I know that one, Discus.com, DoubleClick.net, I've heard of them, are all providing JavaScript files. So when I'm actually trusting CNN.com, I end up trusting all of their partners as well. So all of this content coming back, what can we do about it? Well, traditionally on the network, we've seen technologies such as deep packet inspection. And deep packet inspection, unfortunately, has a limited view of content. It's either scanning a series of packets, it's holding information, it's doing a good job, it's seeing everything come through, but it doesn't see it in its entirety. And to use this matrix from the movie The Matrix example, we can see on the left side, it's very difficult for us to see with a small portion of the content flying through exactly what the threat is. But when we go to what we call deep content inspections, we have the full content object available to us. We can clearly see what's going on in this image, we can see that there's potentially a threat. Now, this is the definition of deep content inspection. It gives 100% of visibility of content, not just packets, URLs, or headers. And we also know that content-based attacks, such as those induced by HTML5, can be discovered by a DCI on the network.
Very interesting. I like the matrix reference there, Joe. Let's see what our audience thinks. We have another poll question here. What is the significant difference between deep packet versus deep content technologies, in your opinion? Nothing. They mean the same thing. Deep packet looks at the headers, whereas deep content looks at the payload. Or deep packet scans a limited window of headers and content, whereas deep content reassembles the entire headers and content for scanning. Or not sure. And we'll just take a second for everybody to answer and see what folks think about that. Great visual. Okay, great. Well, thank you for posting your answers, and let's take a look at your responses. And Joe, keep going. This is interesting information.
Thank you, Alison. Yeah, I think probably the most accurate and simplest description will be deep packet scans a limited window of headers and content, whereas deep content reassembles the entire headers and content for scanning. And this is obviously a very complex topic, but it's a very clear differential. If I have random access to the entire content object in memory, we're defining that as deep content inspection. If I have only limited visibility of that content at any given time, we're calling that deep packet inspection. So let's just review security here for a second, just so that we can, before we move on. So we know that HTML5 is a collection of powerful technologies and very beneficial. We also know that adoption of HTML5 technology is very strong by both online organizations and browser vendors. So this is not something that goes away. We also have seen traditional security tools may not defend against the content and protocol concerns, specifically WebSockets in HTML5. And this is where we feel deep content inspection protects HTML5 content where traditional tools can't. And we'd like you to ensure your security vendor supports deep content inspection plus HTML5 WebSockets in order to defend against HTML5 introduced attacks. So this next section, we'd just like to spend a few minutes just talking about the specific implementation of deep content inspection. Our WedgeOS inspection platform by Wedge Networks accesses the content, secures the content. This is kind of a high-level description of how the technology works. So the chief challenge with deep content inspection, it's a new paradigm, and it's always been the three pillars and the three trade-offs have always been accuracy, performance, and integration. And what I mean is, with accuracy, we've already seen where having full access to the content in memory improves the accuracy of the service, whether that be scanning, something like antivirus. Performance, of course, capturing this content obviously takes a performance hit. And so performance is a chief concern when implementing a DCI solution. In addition to that, when we talk about content, we're talking about layer 7 on the OSI model. And typically, integration into a network cares about things like level 2 to 4. In other words, we want to be transparent on the network. And that's where integration is usually very difficult in layer 7. The WedgeOS platform solves these three things in what we think is a very elegant solution. It's a high-performance, full content-based, and fully transparent, layer 2 transparent solution. As content runs through WedgeOS, we can apply content services, and our traditional services or our existing services, for example, these are all provided by our partners, things like antivirus, anti-spam, content controls, reputation controls, data loss prevention, those type of things. But in addition, the power is really in our integration services. So we have OEM vendors that rebundle our technology to provide their own solutions. We also have custom services that we provide to technology partners. And to give you a kind of a good idea on the differentiator, many of our technology partners were traditionally endpoint provisioners. So they provided either anti-spam or antivirus or some other service on an endpoint server. we've moved them into the network. They can now run on the network through the Wedge OS, and we'll go through a little bit about how that works in the next slide. So this is a real-world result in our Wedge labs. Now, we obviously know that if no protection in your organization, hitting that HTML5 website, you're going to see that content will get delivered, but not necessarily stopping malware, viruses, etc. Now, with competitors, traditional competitors, as we've discussed, next-generation firewalls, web application firewalls, secure web gateways, content inspection appliances, there's a full list of acronyms there. But what we've seen in our labs is traditionally the clean content either hasn't been delivered because it doesn't support protocols such as WebSocket, or it's delivered but not scanned. And in that case, the viruses and malware haven't been stopped. In the case of Wedge Networks appliances, of course, the clean content is delivered and viruses are stopped, malware is stopped through protocols such as HTTP, of course, and of course WebSockets. And just to give you a flavor of the types of solutions that the Wedge OS can come bundled with, we have the package solutions. So we have a product called vSecure, which is the turnkey solutions for customers. And these are transparent appliances that perform all of our value-added services, are all provided on the same box. We also have VMware integration. And, of course, we have cloud and private cloud implementations. In addition to that, we have technology partner solutions. And so this is where partners take, and I've mentioned this previously, they take Wedge OS and potentially our hardware and definitely the software, and they can run solutions on the network that traditionally they haven't been able to run. And this has been a winning formula. This is also a big differentiator. If deep packet inspection gives access to full content, then we would see that DPI vendors would also be able to provide this to our technology partners. And what we have seen is that that's not the case. Deep content inspection is what's required to run these endpoint solutions on the network. So that about wraps up my presentation. I just wanted to say, if you want to learn a little bit more about HTML5 security, of course you can contact me directly. We can go to sites like ANISA and HTML5sec.org. WebSockets.org is also really great for learning a little bit more about WebSockets, so there's a lot to learn there. And for hands-on HTML5, HTML5rocks.com does a great job of giving real live examples of all of these features and helping to differentiate them in your mind. Of course, Wedge Networks, just a review, are security solutions protecting organizations and partnering with technology providers. And if you would like to reach us at any time for any reason, you can reach us on our 1-800 number or 188 number, I guess, info@wedgenetworks.com. We're going to work on some questions here now, I think. And then also in person, we're going to be at RSA in San Francisco, booth 153. And we'll also be at Mobile World Congress in Spain, if you're lucky enough to be in Spain at the time, in Barcelona, I believe. And that's booth 2A97. We'd love to see you, and you're free to call us and book an appointment, and we can spend some time with you and talk about this type of stuff. And I think we can ask questions now.
Yes, well, we have questions from some folks who are here now. This question comes from Bob, and he asks, do you see WebSockets intentionally being used to avoid firewalls and web gateways?
I mean, certainly we do. In the case, especially with today's targeted attacks, folks will spend a lot of time, hackers will spend a lot of time looking for all of the avenues of access. And if they can craft something that is going to work, a bit of JavaScript, for example, that will tunnel something through WebSocket that otherwise would have been retrieved through HTTP, for example, certainly that could be a vector. So I'd say yes.
Okay, great. And this one is from Jeff, and he says, can you explain further why traditional security solutions can't handle HTML5 content?
Right. Okay. We went into a little bit of that. To go through it a little bit again, let's talk about we've talked about the content itself. That's a really important part, having full access to the content. With WebSockets, for example, we don't have all that descriptive information. And technically, in order to identify the content of a file, there's many different tests that a vendor would potentially have to act upon it. And some of those tests might look at the few bytes of the header. They might need to look at the tail end of the content of the file, and then they may need to read information in between. And in addition to that, content could potentially be zipped content. It could be something inside a zip file, inside a tarball, et cetera, et cetera. So for all of these reasons, we think that it's essential to actually have the content in its entirety to be able to perform these types of services. In addition to that, we think that with the mobility and the ubiquity of mobility, we think that the endpoint solutions, for example, are obviously going to have a very difficult time working on these mobile devices. And the other component, of course, is location. So where do you put HTML5 defenses? And it's our opinion that you put those at the network, at the point of entry. So you stop it at the point of entry, and then you're not worried about it afterwards. I hope that answers it in a little bit more detail.
I think so. Here's a question from Julie, and she says, it seems like the browser will become an OS. What does that mean for security?
Right. So that's a really good question.
Yeah.
I think it's actually a good thing. I think that, we have competition. So we have many browser vendors. This is an open standard. They all can choose to have their own implementations, and we can choose which implementation we'd like to use. The browser vendors themselves, some of this is open source, like Chrome and Chromium is an open source project, Firefox. And so there's a very good likelihood of best-of-breed sharing as well. And these types of functions, that doesn't tend to occur in the operating systems. And so I think that, we're going to have more choices. It's going to be a better marketplace for the growth and the evolution of these choices and their security implications, of course. And on top of that, I think that the holistic perspective around security just means that the sandbox browser is yet one more abstraction away from your hardware, which I think is always good in security.
Do you think any particular browsers are better situated than others, or are they all doing a good job in terms of being positioned for this?
I certainly think, obviously, Chrome, Google is a big proponent. Apple obviously is a big proponent, especially for the mobile devices, iOS.
Right.
But when you browse around in the user groups, et cetera, there's a lot of participation from many of the vendors. And, of course, Firefox and Chrome, I think, have the most open participation. And no doubt Apple and Microsoft may be a little bit more behind closed doors. Yeah,
that makes a lot of sense. Can HTML5 functionality be disabled in the browser? And that question comes from John.
That's a very good question. Unfortunately, in many cases it can't. So it's almost an all or nothing thing. Because all of the vendors are implementing these features, I know in some versions these features were considered experimental. And because of that, you could go into their configuration flags and you could potentially disable small subsets of features. But my experience has been that would be very difficult to do in an organization at a large level. And those config parameters tend to expire anyway on the next release when it becomes an official release feature.
I see.
So, no, in a short answer.
Here's an interesting question, especially as beginning you were saying about obviously the increases in productivity and so forth that HTML5 is delivering. With all these new features in the browser, won't the browser use up a large amount of memory and CPU? And that question comes from Mike.
Another good question. So I've been asked this question before. Excuse me. But my general answer would be, I think we're in a better position than previously. So if you can imagine, today's browser is not just a browser, but a series of third-party plugins. And in many cases, those third-party plugins would probably include redundant algorithms, redundant code that maybe already exists in the browser, like maybe compression codes and decompression and video codecs, et cetera, et cetera. And you end up with a ton of duplication. And so I think in terms of the browser implementation of all these features natively, I actually think that the browser footprint will go down overall with respect to the plugins, the previous plugins.
Oh, yeah, that makes sense. And certainly in terms of having to continuously upgrade the various plugins that we all needed,
That's right.
that onus will disappear. Here's a question from Jim, and he asks, what's the difference between Flash and HTML5 with WebSockets?
Okay, that's a good question too. So Flash does have its own concept of sockets, but they tend to be, I think, raw sockets. So they're not well defined. There's no specified port, other than I think maybe the policies come on a specific port. So it's much looser defined how Flash sockets work. Whereas WebSockets being, it's a transparent standard. They're natively implemented by all of these browser vendors. I think they're just going to be a higher adoption rate. I'm not sure what the adoption rate of Flash, unfortunately, is, because there's just not a lot of statistics around that. That's a good question. It'd be something really interesting to look into around the actual usage of the Flash sockets. But I'm sure that interactive apps require those for Flash as well.
Okay, great. Let's see, we just have time for one more question, and this one comes from Ethan. And he asks, if there's no identifying information in WebSockets, how can it be scanned?
Right. Okay, so we touched on this a little bit, but specifically, we know that, for example, endpoint security solutions have none of this envelope that the protocol has. There's none of this descriptive envelope. So they've traditionally not had the ability to rely on that. They've had to introspect on the content, and they've become very good at introspecting on the content. And this is one of those reasons why I think it's so essential to have this content fully available, because many of our partners do random searches through the files to actually identify the content, zero in on the content of interest, potentially apply some logic to it, zoom back out, do some other work. And I think that allows us, without header information describing this content, our partners generally don't need that, right? And so it's only for partners that may do URL reputation type of things where that would even be unavailable. But for our traditional vendors, like antivirus, for example, they'll go in and they'll actually figure out what the content is directly. They won't rely on the header information at all.
Oh, okay, that makes sense. Great. Well, that is unfortunately about all the time we have today. I'd like to thank everyone for joining us. We hope it was valuable to you. Also, a special thanks to our guest, Joe Bullman, for his time and insight. And thank you so much to Wedge Networks for sponsoring today's event. If you missed any part of this presentation, remember it will be archived shortly so you can view it again or refer one of your colleagues to it. You can also download the slides. Finally, there is a short survey up on your screen. Please take a moment to fill it out. Again, my name is Alison Diana. Thank you and have a great afternoon.